Hello everyone, in this video we shall start our machine learning concepts from the internal test 2 of the section B. And so the first question, which is the 11th question, is transforming raw variables into more informative ones is called. So just like we transform raw data into information, we transform raw variables also into informative ones. So this process is called as feature engineering. Predicting a numeric value such as salary is an example of. So sometimes we have missing values and we just know that this should be a numeric value, and when we predict it, it's called regression. A model that fits training data perfectly but fails on new data suffers from dash. So sometimes what happens is that we use a model which was working really nicely on the training data, but when it actually is brought to a new data for a second test or for confirming if it works or not, it fails. So this situation is called overfitting. Dropout and wait penalties are example of dash methods. These are just common regularization methods that we use. Training multiple diverse models to improve accuracy is known as dash learning. So what we do is we train multiple different kind of models, because some model might work, some might not work. So we can get a more accurate one if we train multiple ones, and this process is known as ensemble learning. A simple reference model for comparison is called a dash model. So when we have a perfect working model, we just get a reference model for comparing it and how its parameters are better, and that model which we are using to draw the comparison is known as the baseline model. Independent and random training samples are described as IID data. Parameters tuned before model training are called. So before training a model, we actually tune our parameters, and they have a special term called hyperparameters. Comparing two versions statistically to perform which performs better is called dash testing. So during the testing stage, sometimes we might have two versions of a model and we need to check which one is performing better. So we call it A/B testing. It's like having a model A, model B, so A/B testing. Next question says normalization typically rescales numeric features to the range. So simply asking the range of numeric normalization, which is 0 to 1. The difference between train and test performance measures model generalization. Bias sampling in data can cause dash bias. So simple, it's given in the question. Bias sampling is biased in data collection, so what will it cause? It will simply cause a sampling bias. So that's it for this video. In the next video we'll head towards the section C of deep learning. Thank you for watching.